Imagine a ribbon-cutting ceremony at a brand new multi-million-dollar rare earth refinery somewhere in the West. The politicians smile for the cameras, they give passionate speeches about energy independence, they boast about secure, allied supply chains. It took a decade of bureaucratic fighting just to get the permits. Private investors finally wrote the checks. The financial models looked flawless. Then the factory actually opens, and immediately something strange happens. The global price for their exact mineral quietly drops. It doesn't just dip, it crashes. It falls so perfectly and so deeply that this shiny new facility bleeds cash the moment it turns on the machines. The executives stare at their screens in disbelief. They blame a sudden market slump. They lay off staff. They wait for a rebound that never comes, and eventually they quietly padlock the gates. But here's the unsettling truth. There was no natural market cycle. There was no invisible hand of supply and demand. Those executives thought they were competing against other mining companies. They weren't. They were competing against an entire sovereign system, a deeply integrated machine linking mining, processing, state finance, and export controls. A system that can suppress a price on the other side of the world just to starve a new competitor before it takes its first breath. For years, Western governments have clung to a comfortable illusion. They believed they could build independent supply chains if they just permitted more mines and attracted a little more private capital. But they demanded an impossible paradox. They wanted resilient, non-Chinese supply chains, but they insisted on paying China-shaped prices to get them. They refused to pay the premium for security. Now that illusion is finally shattering. In Evian-les-Bains this week, a tense realization is sweeping through G7 negotiations. The market price for the materials powering our defense systems and our tech grids is not a neutral signal of value. It is a weaponized number. It is dependency perfectly disguised as price discovery. And as the Pentagon begins deploying radical new AI tools like the Open program to calculate what these critical minerals should actually cost without systemic manipulation, it leaves us with an echoing, dangerous question. How do you fight a price war when your opponent controls the very concept of the price?
To really grasp the sheer gravity of that question, we have to look at how this system was actually built on the ground. I was recently reading this incredible account from a European supply chain auditor, and he was sent over to evaluate this sprawling industrial park in Inner Mongolia. And the way he describes it, it just completely shatters the entire Western assumption of how an industry operates. Well, so Elias is standing on this massive steel gantry, right, looking out over a facility that basically stretches as far as the eye can see. And he notices the dust on his boots. It's this raw earth tracked right in from the Baron Obo mine, which is just a few hours away.
Wow, so the mine is right there.
Exactly, but right beneath him, literally under the hum of these massive industrial ventilation fans, that exact same raw earth is already being processed, shaped, and spun into polished neodymium magnets.
Okay, let's unpack this for a second, because that physical proximity is wild to me. You have the mine, the chemical refinery, and the advanced high-tech manufacturing all operating in the exact same airspace.
Yeah, it's totally unified. Yeah. And Elias describes holding his clipboard, looking at this, formal cost analysis rubric that his board back in Stuttgart had given him.
Right, the typical corporate spreadsheet.
The board had been talking endlessly about competitive sourcing and diversifying supply because they assumed they could just, negotiate a slightly better margin with one specific factory somewhere in that chain.
Right, like treating them as separate vendors.
But as Elias watches the shift change, and he describes literally thousands of workers in these blue uniforms moving with this incredible tidal precision across the complex, it finally dawns on him. The refinery he is auditing doesn't just sell components to the battery plant next door.
They aren't vendors at all.
No, they're blood vessels in the exact same state-backed Leviathan. There are no isolated profit margins being fiercely negotiated between the smelter and the assembly line. The entire flow of material is commanded by this invisible hand of quotas, massive subsidies, and total strategic alignment. Elias actually describes taking his pen and just crossing out the entire cost analysis section on his form.
Because the math he learned in business school just doesn't apply there. Profit margins at a single factory don't matter if the whole thing is one giant organism.
The organism survives together.
It's like, if we think about how Western supply chains are usually built, it's super fragmented. You have a mining company trying to maximize its own profit, a shipping company trying to maximize its profit. It's a group of soloists trying to outplay each other. But this integrated approach in Inner Mongolia, it's like a finely tuned orchestra where every single instrument is playing from the exact same sheet music.
And framing this, objectively, it is a brilliantly successful 30-year strategic masterclass. China successfully linked mining, refining, and downstream manufacturing to create what is arguably the most highly resilient critical minerals ecosystem on the planet.
It really is a marvel of industrial planning.
And to understand how it works, you have to look at the 5 stages of integration that this system seamlessly connects.
Okay, walk me through the stages. Stage 1 has to be the mining.
Stage 1 is mining and ore processing. So pulling bastnasite and monazite out of the ground, that's what you picture when you think of mining. Massive trucks, huge open pits.
Yeah, digging up the dirt.
But in a Western model, that dirt gets loaded onto a ship and sent across an ocean to the highest bidder. In this integrated system, it flows immediately into stage 2, which is separation and refining. And this is where the system is just light years ahead.
I always hear about the refining bottleneck. Why is separating rare earth elements so notoriously difficult, like mechanically speaking?
Well, think about where they sit on the periodic table. They're clustered together, and their atomic diameters are fractions of an angstrom different.
Okay, an angstrom is what, like a billionth of a meter?
Yep. Something incredibly tiny like that, yeah. So they behave almost identically in chemical reactions. You can't just heat the rock up and melt the copper out like traditional smelting.
Right. So how do they actually isolate them?
They use these incredibly complex chemical isolation steps. It's called countercurrent solvent extraction. You basically dissolve the crushed ore into this intensely toxic acid bath and then introduce a highly specific organic solvent. Because the elements are so chemically similar, one element will have only a microscopic preference for the organic solvent over the acid. A single pass does almost nothing. You have to run this mixture through hundreds, sometimes thousands, of sequential mixer-settler tanks.
Wait, thousands of tanks? Just to separate out one specific element?
Thousands. Mixing it, letting it settle, siphoning it off, repeating it endlessly. It requires massive energy, perfect fluid dynamics, and intense metallurgical expertise, which flows right into stage 3, metallization and alloying.
Okay, so now we have pure powders, and we need to make them into metals.
They create these highly specific precursor materials, blending the pure rare earths with iron or boron. And because the plant is geographically and corporately linked to stage 2, the feedback loop is instant.
Which leads right to the manufacturing step.
Exactly. Stage 4 is component manufacturing, making the permanent magnets, the catalysts, all the high-value items.
The stuff that actually goes into our phones and fighter jets.
Yes. And finally, stage 5 is consumer use and recycling. Because they control the manufacturing at stage 4, they can design the magnets to be easily recycled and fed right back into their own refineries at stage 2.
So it's a completely closed loop.
What's fascinating here is that by vertically integrating these 5 stages, incredible economies of scale and technical expertise are achieved. The system thrives because it treats the entire supply chain as a single cohesive organism. It optimizes for long-term stability and holistic growth rather than demanding short-term, isolated profit margins at each individual step.
And that highly successful ecosystem completely exposes a fundamental flaw in traditional Western market thinking, right? Because it creates this massive paradox.
A paradox of price.
Because Western nations, they look at this and say, well, we want resilient, independent, non-integrated supply chains. We want our own standalone mines and factories. But they're demanding that these independent nodes survive at prices set by the integrated ecosystem.
Which is an impossible paradox.
Right. You can't demand resilience and independence, but then insist on paying China-shaped prices to get them. Resilience is not free.
No, it's not. And expecting non-integrated supply chains to magically match those integrated prices leads to inevitable failure. This gets into the concept of system power. The market price you see quoted for these critical minerals is not a neutral arena of supply and demand.
It's totally artificial.
Exactly. It is a strategically shaped number. When a quoted price on a trading screen hides deep state subsidies, streamlined environmental compliance, fully integrated inventories, and downstream cross-subsidies, it is no longer a traditional market signal.
It's just a reflection of the system's overall power.
And if Western countries misread that signal, they suffer from what we call strategic leakage.
Strategic leakage.
It's this compounding vulnerability. Imagine a Western government subsidizes a local rare earth mine. Great, you have the ore. But because the market price for refined minerals is heavily suppressed by the integrated system, no one can afford to build a refinery next to your mine.
So you just mine the rock, but then you have to ship it right back to the integrated system to be processed anyway.
The strategic value evaporates, the leakage happens. Or say you do manage to build a refinery, but the price benchmark remains tied to external integrated materials. Your new refinery is constantly bleeding cash. The vulnerability simply shifts one step deeper down the chain.
Right, but let me push back on this a little bit, because it sounds like we're saying the West operates this pure free market and the integrated ecosystem is this uniquely subsidized giant. But every major player intervenes somehow, right? I mean, Western governments hand out billions in tax credits, green energy loans, fast-tracking permits. So what's the actual difference? Aren't we just doing the same thing?
We are intervening, yes, but the difference is the architecture. When Western governments intervene, it's usually just isolated, disconnected subsidies. A grant for a mine here, a tax break for an EV plant there. The integrated ecosystem interventions add up to a cohesive, engineered system.
So they architect the whole chain while we just throw money at random points and hope a chain forms.
And realizing that the quoted market price is essentially a weaponized illusion has led the Pentagon to do something incredibly radical. They are trying to redefine value through technology.
Right, the DARPA Open program. This is such a cool story. There's this data scientist, let's call her Sarah, and she's sitting in this humming server room. You can practically feel the low vibration of the cooling fans in your teeth.
The glamorous side of data science.
And on her screen, she isn't looking at a spreadsheet. The DARPA Open model is rendering the entire global cobalt market as this living constellation of data nodes.
Just a massive, interconnected map of the industry.
And she has fed this AI everything. Shipping manifests, satellite imagery, tracking physical stockpiles, London metal exchange rumors, everything. And the algorithm predicts a sudden, massive price shift in cobalt before the cargo ships even leave the port.
It sees the market manipulation before it actually hits the trading floor.
And her secure line flashes. It's a European diplomat calling from Brussels, and his voice is just laced with panic because he realizes what this tool means. He asks her, if your machine sets the baseline, who governs the machine? Yeah. And Sarah is just staring at this predictive curve on her screen, feeling the absolute absurdity of outcalculating a global monopoly using artificial neurons. Her finger is hovering over the enter key, burdened by the fact that she is literally rewriting the balance of global power.
Because to deconstruct the OPEN program, which stands for Open Price Exploration for National Security, you have to understand its core mission. It's not just a fancy price tracker.
What does it actually do differently?
It ignores the quoted market price entirely. Instead, it analyzes fundamental input costs from the ground up. It looks at local labor wages, the energy needed for processing, logistics, and real-world environmental compliance costs.
So it calculates what it actually costs to make this stuff.
Yes. It constructs transparent structural price predictions based on physical reality, stripping away all the systemic manipulation and hidden subsidies of the integrated ecosystem.
Like, practically speaking?
It means DARPA has created a counterprice.
A counterprice.
It is a formal admission by the defense community that the quoted market price might be structurally false. You can't base your national security supply chain on a manipulated number. You need a new baseline that reflects the actual cost of production without distortion.
But if we connect this to the bigger picture, that has to cause massive geopolitical friction, right? I mean, we saw this exact tension at Evian-les-Bains this week at the G7.
Immense friction, because it brings up huge governance concerns. If an AI developed by the U.S. defense ecosystem is suddenly setting the allied benchmark for what gallium or dysprosium should cost, how do European allies respond to that?
Right, because who decides what the fair price actually is? Brussels doesn't want Washington's computer telling their automakers what to pay for raw materials.
Europe has a very strong preference for transparent transaction-based indexes. They want prices based on actual trades happening on an exchange, not Pentagon-anchored black box AI models.
Which highlights the real-world friction of trying to transition from this free market illusion to a unified allied trading bloc. You have to get everyone to agree on reality first.
And while the diplomats are arguing about AI models in France, the reality of these price supports is already hitting the dirt in the United States.
Which brings us to the Mountain Pass mine in California. There's this really vivid scene with a guy we'll call Marcus. He's a veteran miner there.
Right out in the Mojave Desert.
Yeah, the unforgiving California sun is just beating down. And he's standing by the crushing pit, kicking a loose chunk of bastnasite ore into it. And he's remembering how just a decade ago that mine had basically flatlined.
And went completely bankrupt, yeah.
Rusting equipment, empty pits. But now the heavy machinery is roaring back to life. And it's not because of free market capitalism. It's because in a massive partnership with the Department of Defense.
The DoD basically stepped in to save it.
Right. And Marcus is standing there touching this folded memo in the breast pocket of his coveralls. And the memo details these guaranteed price floors. And he has this deep internal conflict.
Oh.
Well, he's this former free market purist, right? You mine it, you sell it, the market decides. But now he realizes he is acting essentially as a defense contractor. His product is entirely shielded by a government that is willing to pay a premium.
It breaks all the traditional rules of mining.
But as he watches the new conveyor belt spool up, he just feels this weary, practical relief. Because keeping the local families fed and actually building these critical magnets means he just has to accept these new rules.
And we really need to dissect the specific financial structure of that MP Materials deal because it is unprecedented.
And the numbers are crazy.
So first, you have a $400 million DoD investment straight into the facility.
Which is massive.
Huge. Then, a commitment from the government to purchase their magnets for 10 straight years. Guaranteed demand. But crucially, the linchpin of the deal is a 10-year price floor of $110 per kilogram for NdPr products.
Neodymium, praseodymium.
$110 per kilogram.
And to put that into perspective, what was the actual market average at that time?
The artificially suppressed global market average was $52.
So the market says it's worth 52, and the Pentagon says, we will guarantee you 110.
And this functions like a modified contract for difference, a CFD.
Explain how a CFD works in this context.
It's brilliant in its simplicity. If the global market price falls below $110, say it drops to $52, the government steps in and pays MP Materials the shortfall. They get their $110 no matter what.
So they can never be starved out by a price crash.
But if the global price spikes because of a shortage and it rises to, say, $150, the government shares in the upside. MP Materials doesn't just get to pocket a massive windfall at the taxpayer's expense.
Smart. It caps the bleeding, but also caps the gouging. If you look at MP's fourth quarter 2025 results, they reported $51 million in price protection agreement income.
$51 million just from the government making up the difference.
And that wasn't just a minor top-up to make their spreadsheets look nice. That $51 million was the fundamental difference between viability and a massive operational loss. It is the explicit, revealed price of redundancy.
The revealed price of redundancy.
Because it proves exactly what it costs to exist outside the integrated ecosystem.
It absolutely proves it. And it signals the definitive end of the free market baseline for critical minerals. We can no longer pretend that commercial value and strategic value are identical.
They're completely different things.
Public-private partnerships and government-backed price supports are absolutely necessary now. You cannot develop reliable supply chains outside conventional market mechanisms without them.
But, you know, doing a one-off deal like MP Materials is great for one mine, but we're talking about what, 54 different critical minerals?
At least 54, yeah.
You can't have the Pentagon handwriting bespoke contract for difference agreements for every single mine on Earth. A much broader architecture is required to actually bridge this gap.
And that is exactly where Project Vault comes into play. The proposal for a multilateral commercial stockpile, or the MCS.
Project Vault. Sounds like a sci-fi movie.
It does, but it's a very real, deeply structured public-private partnership. Now, when people hear stockpile, they usually picture a giant government warehouse hoarding rocks. But the MCS functions as three very dynamic instruments in one.
Okay, what's the first instrument?
First, it is a physical reserve. The plan is to hold about 12 months of peacetime demand for the top 20 high-priority minerals, just sitting there, ready to be deployed if the supply chain gets cut.
Okay, a strategic buffer.
The second is a demand aggregation mechanism. Let's say you're a major wind turbine manufacturer. You are terrified of a gallium shortage. You can pay a premium to the MCS, like an insurance policy, to pre-fund your supply certainty.
So all these massive private companies pool their money and tell the stockpile, we guarantee we will buy X amount of material from you if things go bad.
Which leads directly into the third instrument. It acts as a project finance enabler.
Oh, because now the stockpile has guaranteed buyers.
If a new marginal mining project needs a $1 billion loan from a bank, the bank usually says no because the market is too volatile. But if that mine has a guaranteed purchasing contract from the massive pre-funded multilateral commercial stockpile, suddenly that mine is bankable.
It uses private manufacturing anxiety to finance new raw material extraction.
It's a beautiful mechanism. But as we know, history is littered with failed stockpiles.
But, hasn't this been tried before?
Have you ever looked into the International Tin Council from the 1980s?
The tin cartel, yeah, that was a disaster.
An absolute catastrophe. And the Federal Helium Reserve is another great example of how this goes wrong.
Why did they fail? Because on paper, a stockpile makes sense.
They failed because of their rigidity. The Tin Council tried to use rigid price pegs. They drew a line in the sand and said, we will buy unlimited tin to make sure the price never drops below this exact dollar amount.
Which just encouraged massive overproduction from countries outside the cartel.
And they were wildly overleveraged. They borrowed billions from banks to buy tin they didn't need just to defend the peg. Eventually, they ran out of money, the market collapsed, and they defaulted.
And the helium reserve failed for the opposite reason, right? They didn't buy too much to defend a peg. They were legally forced to sell it all off.
Congress got tired of the debt and mandated a complete sell-off by a certain date. Lack of dynamic sunset clauses. They dumped cheap helium on the market, destroyed all private investment in helium extraction, and when tech demand spiked later, there was a massive global shortage.
So if the history is that bad, why is Project Vault going to be any different this time around?
Because they learned the lessons.
Yeah.
The modern solutions built into the MCS are totally different. First, instead of rigid price bands, they use floating price triggers.
So the intervention price moves with actual market realities.
And they use digital price discovery, like the DARPA Open tools, to know the true structural value of the materials in real time.
They aren't flying blind anymore.
Right. Plus, the stockpile is capitalized fully by participating governments for full boom-bust cycles, not leveraged with commercial bank loans. And finally, dynamic sunset clauses. If a stable, independent market actually develops for a mineral, the stockpile automatically slowly winds down its position.
It knows how to exit the market.
And the governance structure reflects this flexibility. It's built on a tiered architecture.
Tiered how? Like politicians versus businessmen.
At the top, you have a sovereign board of directors. These are the political appointees, the diplomats for the G7 nations, setting the grand strategy.
The people arguing at Evian level.
But beneath them is the commercial operations board. These are private operators, commodities traders, people who actually understand the flow of materials. They manage the day-to-day procurement via open market exchanges.
So the politicians aren't micromanaging the trades.
The commercial guys can react to market dips in milliseconds without waiting for a diplomatic summit to approve a purchase. And the ultimate goal of this entire multilateral approach, coordinating with allies through frameworks like Forge, is really counterintuitive.
What is it?
The goal isn't to replace the free market forever. The goal is to stabilize these commercial markets and create enough liquidity that true independent spot markets can eventually thrive on their own.
They're building an artificial ecosystem just long enough for a natural one to grow. Well, when you synthesize all of this, from the massive unified factory floors in Inner Mongolia, to the AI server rooms modeling shadow prices, to the DoD writing checks in the California desert, it's clear that the critical minerals price war has completely moved beyond geology.
It's not about who has the best rocks anymore.
It has moved entirely into institutional design. The era of treating strategic materials like ordinary commodities, just trading them blindly on a screen, is effectively over.
In the realm of strategic materials, the market no longer organizes the system. Instead, the system has become the market, and survival belongs entirely to those who can engineer the most resilient architecture.